Hello everyone. In this video, you'll learn about trigonometric substitutions. There are three types of trigonometric substitutions. When the integrand is or contains the square root of a constant squared minus x squared, use the trigonometric substitution x equals the constant times sine of t, where t is between minus pi over 2 and pi over 2 inclusive. When the integrand is or contains the square root of a constant square plus x squared, use the trigonometric substitution x equals the constant times tangent of t, where t is between minus pi over 2 and pi over 2. When the integrand is or contains the square root of x squared minus a constant squared, use the trigonometric substitution x equals the constant times secant t, where t is between 0 and pi inclusive but not equal to pi over 2. To evaluate the definite integral of square root of x squared minus 3 over x from minus 2 to minus square root of 3 with respect to x, I'll use the fundamental theorem of calculus. The integrand contains the square root of x squared minus a constant squared. Because the constant equals square root of 3, then the trigonometric substitution I use is x equals square root of 3 times secant of t. T is between 0 and pi, inclusive but not equal to pi over 2. Because x is between minus 2 and minus square root of 3, it follows that t is between pi over 2 and pi, where t is a second quadrant angle. As a result of that, I'll write the antiderivative in terms of the reference angle, t prime, which is an acute angle. In step 1, I rewrite the integrand in terms of t. The differential of x will be replaced by the square root of 3 times the derivative of secant t times the differential of t. With those substitutions, the initial integral with respect to x becomes an integral with respect to t. The next step is to evaluate that indefinite integral with respect to t. As t is between pi over 2 and pi, where t is a second quadrant angle, I'll write the antiderivative in terms of the reference angle t prime, which is an acute angle. I want to remind you that tangent of t equals minus tangent of t prime, and secant of t equals minus secant of t prime. After the integral with respect to t prime, the reference angle has been evaluated, each component has to be written in terms of x, the initial variable of integration. As t is between pi over 2 and pi, the secant function is a one-to-one function. The equation x equals square root of 3 times secant t can be solved for t. It follows that t equals arcsecant of x over square root of 3. As secant of t equals minus secant of t prime, it also follows that secant of t prime equals minus x over square root of 3. To express trigonometric functions of t prime in terms of x, I'll use a right triangle having an angle equal to t prime radians. Because secant of t prime equals minus x over square root of 3, it follows that the hypotenuse of that right triangle equals minus x and the adjacent side equals square root of 3. Using the Pythagorean theorem, the opposite side becomes square root of x squared minus 3. With all the sides known, any trigonometric function of t prime can be expressed in terms of x. I replace t and tangent of t prime by expressions in terms of x, and the answer in terms of t prime becomes an answer in terms of x. Finally, the fundamental theorem of calculus is applied. The answer to the given definite integral is calculated as the difference of the antiderivative f at minus square root of 3 and the antiderivative f at minus 2.